So if we have y equals u, and I'll put vw together, and we differentiate, think about this, we're going to differentiate the first, leave the second, plus differentiate the second and leave the first. So that will be times u. Now this bit's fine, but this bit, when I differentiate the inside here, it's chain rule, so I need to not even chain rule, it's just two, so it's product rule really. So when I differentiate this bit here, I really need to differentiate the first times the second plus differentiate second times the first, and there's u there. So altogether I've got u dash vw plus v dash uw plus w dash uv. So each of them are dashed with the other two basically. Alright, so that's going to be our formula. We want the derivative of one times the other two, and so if there are three terms, which in this case there are, and in this case there are, we're going to differentiate one times the other two. So let's have a look at the first one. If we differentiate x to the 5, so we get 5x4, then we're going to write these two, so the other two. Okay, plus, now we're going to leave the first one and differentiate the second one, so that will be, I'm going to put it here, I'm going to put 4 here, 4 x minus 1 cubed, and then write the other one, the third one. Alright, and this time we're going to have the x to the 5, we're going to have the x minus 1 to the 4, and this time we're going to differentiate the last one, which is 3 x minus 2 squared. Okay, so I mean, we could just leave it like that, but the other thing is to just have a look at what they all have in common. They all have an x to the power of, can I write that? Yep, that is a 5. I just can't read my own writing. That there is a 5. So at the highest, or they all have x to the power of 4 in them. The highest x minus 1, well really I'm looking for the lowest that one has, and that's x minus 1 cubed is the lowest there. And then they all have an x minus 2 at least squared. So in the first one, we've still got a 5, and we've still got an x minus 1 and an x minus 2. In the second term, we've still got a 4 and an x minus 2. In the last term, we've got a 3x and an x minus 1. Whoops. So this would be handy if you're finding like a stationary point, perhaps, when you want to set it to 0. So if I simplify this inside, if I expand it, I'm going to get 12x squared minus 26x plus minus, that's going to be minus 10, that's it. And it's going to be a plus 10 because it's going to be times by that first. That's going to be a plus 10. Alright, so what I'm going to end up with, I can definitely put a 2 out the front here. So I am going to get x minus 1 cubed, I'm going to get x minus 2 squared. I'm going to have to factorize 6x squared minus 13x plus 5, which we could do by observation. So it should be 1 and a 5, and they're both minus, yeah. So you get something like that. So if you wanted to keep going, you could do that, so then you can find stationary points easily. Let's do the same thing for B. Let's have a look at B. See if so you might want to have a go first, just see if you can do it. So we're going to differentiate x, so you get 1, and then I'm going to write the other 2, and I'm going to write it to the power of a half. Okay, now we're going to differentiate, we're going to keep the x, but I'm differentiating this x minus 2 to the power of 4. And that's still to the power of a half. And then I am going to differentiate. So I'm still going to have my x minus 2 to the power of 4. And I'm going to have my 2x plus 1, but the half's going to come down the front. I forgot to times that, a 2 there. 4x, x minus 2, q, I'm up to that one. So 2x plus 1 is the one I'm doing, and I have to, yeah, sorry, so take away 1, I get minus a half, and then go inside. This one needs a chain rule because it's got a 2x in it, so I need to times by 2, so I'll just put that 2 there. Alright, so what do we have here? they all have x minus 2 cubed in them. And at the smaller, I have to grab the smallest one, which is to the power of negative a half. Alright, so that leaves me with x minus 2 in the first one and a 2x plus 1, because if I add into c's, 1 plus negative a half is a half, which is what we want. In the second term, I've got a 4x and a 2x plus 1 again. And the last term, I'm going to have an x and an x minus 2. So, putting all that together, I don't think is that pretty actually. So they probably don't require us to do that, but just in case we were finding something like a stationary point, I think this gives us something like 11x squared minus x minus 2. Anyway, it's going to give you something. 8x squared, 2x squared, and 1x squared, yeah. Yes. Alright, so if you wanted to change it and write it in terms of, I'm not going to bother going any further than this. This would be a square root x plus 1. Why have I got a quarter there? That should be a minus a half. Alright, so hopefully that works for you too.